Hello, my friends, data scientists, and all dear members of the data science community. After our lessons, two lessons at least, of data descriptive statistics, in which we showed various descriptive measures of statistics like five number summary, mean, standard deviation, and population measures like ZStat. ZStat is used when population is known. After those lessons, all of those lessons were univariate variables. Univariate variables in which we showed you the box plot, histograms, and all those with single variable. Now the time has come for bivariate or multivariate variables, which will allow us to assess the relationship, the association, thereby could be inferred as the causation of dependent variable on the independent variables. Data science community, the dependent variable is usually called response variable, and the independent variables are called the predictors variable. So let's begin that with simple linear regression, and then we can extend that to the multiple regression as well. So begin with importation, import pandas as PD, as PD. Make sure I'm not making typos. As PD. It appears that import NumPy as NP. Okay. And the third thing I'm importing, import mat. Let me import stats models dot API as SM, which will require for statistical modeling, which will require for regression. And then for plotting, import Plotly. Plotly is interactive visualization. Plotly.express as px. And then we will need plt. So for that, import matplotlib.pyplot as plt. Plt. See, this is the notebook is giving me false, highlighting false items. Plotly. And let's go ahead and plt.style.use ggplot. I'm using ggplot just to show the grid in the background as a nice background. Okay, ggplot. All right, those will be our importations. Shift enter, and then let's get some data. Data equals, I'm just going to write some data here. Some data here. And the data is going to be, let's say, sales data. Sales in millions. Okay. I'm going to put some hard-coded data in a list. Say 35 million, 85 million, 76 million, 88 million, 94 million, 92 million, 38 million, 41 million, 39 million, 65 million, 74 million, 77 million, 36 million. I'm just writing some 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. Let's make 20. 36 million, 42 million, 44 million, 58 million, 52 million, and 71 million. So let's see, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, let's make 84 million, 93 million, 97 million. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20. Okay, we have 20 sales data. Okay, so shift enter. So now we have sales data. Let's read the data. We store the variable into data frame. df equals pd dot data frame. pd dot data frame. What are we going to bring in? Data. Here we have data. Okay, so that. But before I read that one column, for example, I can show you one column like df.head will give me 5 top rows of the data like this. You see here we got that. But I want to add some more columns, which is called synthetic data creation. Okay, I want to add some other columns. For that, I am going to say df dot inventory millions. Okay, in inventory millions equals np dot random dot rand int. Okay, so inventory levels we are going to do from say 5 millions to 45 millions. Okay, so this will be randomly generated from 5 million to 45 million. All the numbers in between will be the random. Size, length, how much will that be? Length is going to be df. So we will generate 20 random inventory numbers. This shows the very close to reality, the practical business world. Okay, so let's do similarly another one. df that staff nums. Sales is a function of inventory. That is my theory. Inventory levels as well as the staff that cater to the customers, like to provide customer service, to sell the products. Staff nums. For that also I'm going to calculate with random np random dot rand int. I'm going to calculate the int because staff cannot be float, right? So staff level, let's start from 25 to 75. Okay, and the length, the size of the staff data will be data frame length. Okay, so we have these three, right? For now, we'll just explain this in terms of 2 predictor variables and 1 response variables. Okay, it will illustrate us the multiple regression as well if we desire to do so. Okay, so let's read that now. df dot head. If I read this, I should see the columns, three columns including sales. Okay, shift enter. You see here sales in million, inventory mils, staff numbers. So I want to make sure that if I just do this, every time I run the cell again, the number of inventory and staff changes. That is not good. So I want to make sure that this persists. These numbers that I showed here persist. For that, I need to do this. I need to do np dot random dot seed. np dot random seed. Okay, seed. Any number you can put. I just like 42, so I put 42. Okay, so with this, no matter how many times I run, I will always get these same numbers. Okay, so consistent with the sales, inventory, and these numbers will be persisting. So see here, look. Okay, so the next thing we can do now is, now that we have read the data, the first thing we do, since this is a bivariate analysis, we're going to show you the scatter plot. Okay, scatter plot has one response variable and at least one predictor variable. Okay, so let's do that. I'm going to do with plotly. Okay, so that you can hover over it and can see the value of at that point. Fig equals px dot scatter. Okay, so data is going to be df. X, we're going to put x, say, let's put inventory mills. Okay, inventory, make sure you copy the correct name. Mills, inventory in mills, that is one of the predictor variable. And y, the response variable, is of obviously sales millions. So this is going to show you the relationship between predictor variable and the response variable. And trend line equals OLS, ordinary least square. We're going to show the trend line as well. To show the dots bigger, size equals, I'm going to put staff nums. Okay, so this will show me the fig. Let me run it and see. Fig dot show. Okay, so let's run it and we will see the scatter plot. It's running. We should see some sort of scatter plot. If I did not make some typos. You see here? Now you can see clearly. Look at these. You over here, see inventory millions 12, sales 83 million, and staff number 36 there. So from here you can see the trend is not quite according to what we think. Usually larger the inventory, higher would be the sales, right? But here you don't see that. It's coming down. The inventory level is going up, the sales trend is getting down. But there are some outliers, like there are some values far away from the trend. Many values are far away from the trend. In fact, I can only see one value being on the trend line. So this is, in reality, this is what happens. Okay, so just to satisfy your appetite, we can see here R square also. R square equals 0.099. So its explanatory power of this model is very low. It's only less than 10%. Okay, R square is less than 10. One would expect some better explanatory power, but this is just a simple example of bivariate analysis. You can see inventory levels, what is the response in sales as inventory levels increase. Say per unit increase, per million increase in inventory, what is the response of in the sales? So at the moment it is negative. So to see exact numbers, we have to run the OLS, ordinary least squares method, and read the coefficients. Okay, so for that I am going to run the regression. Okay, so I need to import one more thing. Import stats models dot stats dot outlier, because I want to show you the variance inflator factors as well. Outliers. underscore influence, okay, from I need to write that from, let me make sure I am writing it correctly, from stat models that stats that outlier influence, import, we need to import this, import variance inflation factor. Okay, we need to import that to be able to see the variance inflation factors to identify whether we are suffering from multicollinearity problems. Okay, all right, so now let's run the model. Okay, to run the ordinary least squares regression, x equals df. So we're going to, since we're going to run multiple regression, we need to get more than one variable in x variable, right? So here it's going to be inventory mills, comma, the other variable we have is staff nums. Those are the two predictors we have, right, in our model, staff nums. Okay, so that is the x variable, and we need y variable. Y equals df. You know what y is? Sales in millions, right? Sales millions. Okay, so we specified those. Now x equals sm dot add constant. Add constant. We need to add the constant. Okay, we want to have this regression with constant, not without constant. Constant, what will be in the constant? X-axis, right? X. Okay, the next now is fit. Now let's fit the model. Model equals sm dot ols y x dot fit. Okay, and then print. Let's print the model dot summary. We need all the summary that is available here. Okay, so if we run this, we will get the coefficients and all the details of regression. Shift enter. Okay, you see now, you can see all this here. R squared is the model's explanatory power is 0.24, which is low, and usually people look at adjusted R square, adjusted for the degrees of freedom for the parameters. It is 0.15, low. F statistics 2.72. This shows overall fitness. The numbers not quite significant at 5% level. Okay, and the idea is, the interpretation usually people do is this: coefficients. So inventory coefficient is minus 0.8614. What does that tell us is that an additional increase in inventory, if we add 1 million more inventory, our sale will decrease by 861,000. So you can see in the earlier curve, we saw this negative relationship, you see. So I am now quantifying that with these coefficients. So that is what it is. Similarly, staff numbers. One additional staff added to the staff level will decrease the sales by $591,000. So both are showing the decrease in sales. That means the inventory, the model tells us that inventory is and staff level are not contributing to the sales, which is absurd. Nobody can expect this kind of thing. Okay, so why that happened? Why that happened? Just look at this conditional number. Con number 303, very high. That means the model suffers from multicollinearity, which suppresses values, p values, probability values. Okay, so multicollinearity is the biggest problem because this is a cross-sectional data. Multicollinearity being the problem, the model suffers from that. You want to see the multicollinearity problem? So let's look at variance inflator factors. Okay, if we see quantities of variance inflator factors for each predictor greater than 5, then we say it is a suffering from multicollinearity. Some of the statisticians, data scientists tend to accept the predictor values, VIF values, up to 10 acceptable. But for my case, I am saying any predictor variable with a VIF value greater than 5 suffers from multicollinearity. So for this example, let me show you that and then we'll discuss. VIF data equals pd.data frame, pd.data frame, not data first, data frame. Okay, pd.data frame. I want to make sure you are seeing this thing. pd.data frame and VIF data. I want to make sure this is also data, not that. VIF data, data, also VIF data, and create a column called feature. We need a feature column to show the VIF values in a column equals x dot, see, x-axis columns, x columns, here x columns, and then VIF data, VIF data, VIF data, and create VIF label, VIF equals variance inflator factor. You see, that's why we had that imported. Variance inflation factor of x values, x dot values, x values, comma, I for I in range x dot shape. We are not including the constant, the interceptor. That's why I'm showing you that shape 1. Okay, and let's print it. Print VIF data, VIF data. Okay, VIF data, and let me access the VIF data, access that, and within that let me access that feature. Okay, having accessed all that, now we're going to say not equal to constant, because we don't want constant. Okay, so NST cost. we do not want constant. So we want to show pure variance inflation factors of the predictive variables. So let's run it and see if I did not have typos. We should get some. You see here? Perfect. Look at this table. Feature VIF. Inventory has a variance inflation factor of 1.18. Great. Acceptable level. So this shows the model is not suffering from multicollinearity. Quantitatively, we can see it. Similarly, the staff numbers also VIF very, very small. Quantitatively, we can see that the model is not suffering from multicollinearity problems. So in reality, what does that mean? It means that there are other factors for sales performance, sales increase, other than just staff numbers and inventory levels. Other factors could be the population, the customer base, how many customers are there. Other factors could be the income levels of the customers. Other factors could be what type of store is this, what type of demand is there. Is this an inelastic demand, like demand for the essential items, food and basic necessities, or this is elastic demand, like items like luxuries and substitutes, those kind of things, as well as the availability of substitutes, what is the competition. All these other factors must be taken into consideration before we concluding that our model said there is no effect of inventory and staff levels in the increment of sales. We cannot conclude from this. So the model is not able to explain the changes in sales that are occurring in response to the inventory and staff levels. So that's all we can say for this. So you see, all these things are very logical, explained using multiple regression analysis, and this is an important instrument for data scientists to understand the association of response variable and predictor variables. So I hope you understand this. There is a lot, the whole world, about this multiple regression analysis, about sales analysis, about cross-section data. And this is just an introduction to show you that this is how in real life companies measure the response of their instruments for meeting their goals of increasing sales, that kind of stuff. Okay, so I hope this has been clear to you and I enjoyed presenting you this. So thank you for watching. Thank you for listening. Stay tuned for more advanced analysis. I will be dealing with more statistical analysis with Python pandas in the coming days. More will be coming. Thank you for watching. Subscribe to my channel. This is the place where you will learn everything from a learner's point of view. There are no intricacies, no steps are skipped. So please subscribe to my channel. Thank you. Bye bye for now.